Hi guys, in this video lesson we're going to talk about finding volumes revolving around axes other than the x and y axis. So this is very similar to the last lesson. Um, the basic understanding hasn't changed. If we rotate around a horizontal axis, the function should be in terms of x, and if we rotate around a vertical axis, the function should be in terms of y. So let's talk about writing the general form of a volume for the area R where any cross-section is perpendicular to the axis of revolution. So if we want to find the volume for this shape, well, we know we have this distance here, which would be like a capital R, and that would be a constant, right? Versus this smaller distance here would be our lowercase r, and it'd be found by taking the larger region and subtracting away this curvy function that we have here. That's our f of x. So we could find the volume by integrating from a to b, pi times c squared minus pi times c minus f of x squared dx. Or we could pull out the pi, because they're both being multiplied by pi. Versus over here, our larger radius is just this function, this curvy function, that's been shifted up c. And the reason it's been shifted up c is because the axis we're revolving around is this y equals c axis. And in here it appears to be negative. And that's okay, but it's increased that overall radius that's being revolved. Versus we want the smaller radius, the part being bored away, to just be whatever this constant function is. So the volume we'd found by integrating from a to b, pi times f of x plus c squared minus pi times c squared dx. And this one, we can tell our outer radius is this here. So remember, we're revolving around some constant function. This constant function is y equals c. So if we take this c, this height from here to here, and we subtract away this distance down here, we're left with this distance up here. Then the smaller radius is c minus f of x. So that bigger radius, capital R, is c minus g of x. And the smaller radius is c minus f of x. So we get that our volume is pi times the integral from a to b of c minus g of x squared minus c minus f of x squared. Over here, we can tell this is the longer radius, and that comes from this f of x plus an additional c. And then this smaller radius is g of x plus an additional c. So the volume equals pi times the integral from a to b of f of x plus c squared minus g of x plus c squared dx. So let's look at this concrete example. So we're talking about the square root function. So we know a square root function looks like this. We're talking about x equals 4, so this vertical line here, and y equals 0, so this horizontal line here. So this is the region, and we're revolving this region around this axis. So we can tell that the outer radius is just a constant distance of 4, or 4 minus 0. That would be from here to here. And that this inner radius is going to be the longer distance 4 minus the square root of x. And we can tell that we're using a washer method because we have this hole in the middle. So our volume is going to be pi times the integral from a to b of 4 squared minus 4 minus the square root of x squared dx. And this actually comes out pretty clean to an integral from 0 to 4 of 8 squared of x minus x dx, which comes out to 104 pi over 3. At this point, I don't think it's the integrating that would get to you, it would be the setting up. So let's look at a vertical axis of revolution. Very, very similar here. Every time you're just thinking, what is the larger distance compared to, or largest radius compared to, what is the radius that's being taken out, bored or drilled out? So like this distance here would be a capital R, and this distance here would be our lowercase, so the constant take away the function. Over here, our bigger distance, our capital R, would be f of y plus c, and this little distance would be a constant c. I'm just going to set up what each of these look like as integrals. And so then this volume would be the integral from a to b pi of f of y plus c squared minus pi times c squared dy. So again, the main difference, because we're revolving around a vertical axis, is that things are in terms of y. So then if you look at this one, so we're revolving, the greatest distances from here to here. So that's r equals c minus g of y. The smaller distance is here, so it's r equals c minus f of y. The larger distance, because this is our axis, is from here to here. So it's r equals f of y plus c. The smaller distance is here, so r equals g of y plus c. So we're going to go ahead and jump to example, example 6. So on example 6, go ahead and see if you can sketch out this picture here. Okay, so in this case, when we go to set up this picture, we can tell that y equals x squared looks like this. Y equals 4 looks like this. So we can tell that our outer radius is this distance that goes from here to here. And our inner part is here to here. So we can tell that our outer is 3 minus negative square root of y, and the inner is just 3 minus square root of y. So this is a boring out situation. So we can tell that our volume would be the pi times the integral from 0 to 4 of 3 plus the square root of y squared minus 3 minus the square root of y squared. See if you could finish that one off. If you do it correctly, you should get 64 pi. So let's look at this next one. In example 7, you would sketch up this picture knowing that it's a square root function with twice the normal height of the parent, so something like this. And the line y equals x looks something like this. And so they're going to intersect right here at 4, 4. And we're revolving around this line over here, x equals negative 2. So we can tell that this outer radius is from here to here. So it's negative 2 minus y versus the inner radius is from here to here. So it's negative 2 minus 1/4 y squared. Remember, because y equals 2 times the square root of x, if you rewrite it in terms of x is 1/2 y squared, which is really 1/4 y squared. This again would be something where you're boring it out to find the actual volume. Let's look at example, let's do 8. It's the non-square root function here. So example 8, x equals e to the y, x equals 1, so x equals 1 is this line here, y equals 1, well this is not to scale, but this is line y equals 1, and x equals e to the y would be something like this. So the outer radius is going to be 1 minus the natural log of x, because remember, if x equals e to the y, natural log of x equals y. Okay, and then the inner radius, well, we don't have an inner radius. We don't have an inner radius because there's no gap between what we're revolving around and the shape itself. So this is a disk. So we're going to say the volume is the integral from 1 to e of pi times 1 minus the natural log of x squared dx. So we end up with about 1.371 or 2 for our volume.